Okay, this is problem 3 on quiz 5, and this is on both forms of the quiz. So we want to use implicit differentiation to find dy dx if, well, this is true. So I've got y times e to the x minus x times e to the y is equal to 1. Well, implicit differentiation means, implicit differentiation means just take derivative of everything. So I'm going to take the left side of this equation, take the derivative, and take the right side, and I want to point this out. I saw some people put dx to the right of this. Ddx, you have to put it to the left of something to say, alright, you're reading from left to right, the derivative of what's right after it. Here, to say this is a derivative, you really got to put it right there. Okay. So the derivative of 1. So on the right side, well, derivative of 1, that's constant, that's 0. Okay. On the left side, it's going to take a little bit more. So derivative of, start here, y times e to the x. So use the product rule, derivative of y, let's dy dx. Okay. Times, I'll just leave e to the x, plus y times derivative of e to the x. And derivative of e to the x is, well, just e to the x. Okay. Now we've got minus derivative of the first guy here, so derivative of x is 1 times what's left is e to the y, and then minus x, I'm going to run out of space, minus x, and I've got e to the y here, so derivative of e to the y is e to the y times dy dx. So you have to throw that times dy dx in there. I'm sorry, I'll rewrite this. Alright, so there's rewritten, so it's a little easier to read. So remember, you take the derivative, I've got x times derivative of e to the y. Well, derivative of e to the y is certainly e to the y, except I'm taking derivative with respect to x. Y is not x, so I have to multiply by the derivative of y with respect to x here. Chain rule. Alright, so now, well, my problem said find dy dx. So now I want to get dy dx by itself. So take every term that doesn't have dy dx, move it to the other side. So let's see, that's this guy, e to the y, and this y, e to the x. Okay. Move that over there. You end up getting that is equal to, so negative y, e to the x, plus e to the y is equal to, what do I have left over? Let's say it's dy dx minus x e to the y, oops, there's an e to the x there, minus x e to the y dy dx. Okay. So let's bring this up here. So now to solve this, well, I want dy dx by itself. I've got two terms dy dx in it. Well, how do I just get one term? I can factor it out. I apologize for running out of space. So I get the right side still over here, and here I just factor it out. I'm left with e to the x minus x e to the y. So to get this by itself, we divide out by this term. So we end up with dy dx equals negative y e to the x plus e to the y over e to the x minus x e to the y. And here I've got dy dx equals something. Sure, I've got both x's and y's over here. Make sure they're legible. So x as well. So negative y e to the x plus e to the y over e to the x minus x e to the y. That is the answer.